Clock stat is to user land what lock stat is to the kernel. So if you're chasing application code that is multi-threaded, it's probably using locking primitives in the code, mutex locks, reader-writer locks. Clock stat will give you statistics on those locks. So if you suspect that a piece of code you have running on your system has a lock contention problem, you can use clock stat to figure that out. And INTR stat is interrupt statistics. And so you can get statistics on interrupt activity on your system. In the interest of time, I won't digress too much into that because I have a tendency to rat hole a lot. Okay, and then DTrace user components. We have these things called predicates. One of the things we wanted to do when we were building DTrace is give users the ability to prune data at the source. One of the beautiful things about DTrace is how many people have chased performance problems as part of their job. So I've been doing this since I had hair, which is a very, very, very long time ago. So I've got decades of experience of system has a performance problem. It starts running slow at 2 p.m. It gets better at 2:30. So you write a shell script and you collect SAR and VMstat and IOStat and all that crap, and you redirect the output to a file, and you put it in cron or whatever, and then you wait till the problem surfaces. And once the problem surfaces, you have 500 megabytes worth of data that you need to begin sorting through to try to figure out, okay, the problem happened at 2:33 p.m. Most of you have been there. What happens is in typical performance analysis work, you spend 80% of your time just pouring through the data to weed out what's useful to you, and 20% of your time actually doing real analysis and figuring out what the next step should be. With DTrace, we provide this mechanism through aggregating functions and through the predicate mechanism that allows you to prune the data at the source. The data you get back from DTrace is what you want and what you need. You spend 5% of your time pruning data, you spend 95% of your time analyzing the data and trying to figure out what went on in your machine. So predicates provide a powerful control flow mechanism for your D programs. And then an action is simply, what do I do when the probe fires? What action do I want to take? I can collect data, I can collect and print variable names, I can gather timestamps and do time-based profiling, I enter this function at this time, I return from this function at this time, I can do time-based profiling. There's any number of different things I can do when a probe fires. DTrace facilitates a lot of interesting actions. So this is what a D program looks like. So when we designed DTrace, we actually created a programming language called D. That's just what you needed, right? Another programming language in your life. But if you've done any awk programming, if you've done any C programming, D will come very natural to you. If you don't have any programming experience at all, then it's still a relatively simple language to use. There's actually not that much to it. You basically have a probe, and a probe has those 4 components in its name that I told you about. A probe is followed by an optional predicate. You don't have to use predicates, but you can if you want to create some conditional statements around whether or not you want DTrace to take the action specified in the curly braces. So you've got a probe, you've got an optional predicate, then you've got your probe clause, or what actions to take whenever the probe fires. And that's it. That's a D program. So here's a simple example. I have a provider called the syscall provider, which allows me to instrument the entry and return point of all the system calls, right? And system calls, as you know, are API calls that applications use to have the kernel perform a specific service on its behalf. Read a file, write a file, send, receive a network packet, whatever. System calls are a really, really interesting place to start looking at systems, by the way. If you've ever seen a DTrace presentation or demo before, you've probably seen people use the syscall provider. I use it all the time. And I use it all the time in my day job too, when I'm looking at customer problems, because the syscall provider, the syscall layer in the system, is where applications meet the kernel. So it's a really, really interesting place to start looking to see what sort of load are the applications placing on the underlying system. Am I doing a lot of disk I/O system calls or a lot of network I/O system calls? Am I creating a lot of threads? Am I forking a lot of processes? It's it's a relatively interesting place to look. And just to illustrate again, I'm going to say sorry about that. I'm going to say syscall. So that line, I know some of you may not be able to see, is going to enable the entry point of every system call because I left I left the probe name blank. So remember, whenever I leave a field blank in my DTrace probe specifier, it matches everything. I'm going to match all the system calls. And so every time this system executes a system call, I'm going to say, give me the name of the system call. Probe name happens to be a DTrace variable that maintains the probe name. And I'm going to say, give me the exec name. Give me the name of the process that called the system call. So basically what I did is I just used DTrace to say, instrument the entry point of every system call on the machine. Every time a system call is executed, this probe is going to fire. Every time this probe fires, I want you to collect the name of the system call, which is what's reflected in probe name, and the name of the process. So basically I'm getting a system-wide view of what system calls are being executed on my machine and who's executing them. And you can see that, sorry, it got wrapped around, but I've got a Java process. Wait a minute. That doesn't look right. Wait a minute. So that should be, yeah, so that's, oh, I'm an idiot. Okay, I'm an idiot. Sorry. All right. I don't want to use probe name, I want to use probe func. I used the wrong variable. I used the wrong DTrace variable. Remember I said a probe is provider module function name, and there's a DTrace variable to give you all four of those probe name components. I use probe name, which is always going to be entry. It's always entry. I used the wrong one. I want probe func. I want this field. That will give me the name of the system call. Andy, where are you? You're supposed to be helping me out here.
Don't blame me.
All right. That's better. Right. So now we can see that I've got this Java process that did some poll system calls, some LWP, which are thread system calls. I've got DTrace did a bunch of IOCTL calls. So I mean, with one simple DTrace command, I was able to say, I want to know what system calls are being executed on my machine and who's executing them, and I got the answer, just like that. Very, 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 very intuitive question to ask. Very important question to get an answer to when you're diagnosing a system, impossible to do on anything else. And now I can take advantage of the predicate mechanism that says, all right, I'm not interested in system calls executed by the DTrace command. So I'm going to add a predicate that says exec name not equal to DTrace. So basically what I did is I'm filtering this out. I don't want to see what DTrace is doing. I'm using DTrace. I don't care if it's executing IOCTL calls. So I'm just decided to leave DTrace out. And now you can see I just got this Java stuff. And now I can take it one step further and say all I'm interested in is Java. Because I see that Java processes are executing most of the system calls on my machine. And hopefully what you're seeing here is this methodology that it may not look like much of a methodology, but there is a method to it that you're going to apply time and again when you use DTrace. You're going to start with something that gives you the big picture, and you're gradually going to pare it down using the predicate mechanism and other facilities within DTrace to get more precise answers. I started looking at the big picture. Now I'm just looking at Java. And now all I have is everything Java's doing. Now what if my machine is running more than one JVM? I can simply add, and I apologize if this is hard to read. I'll put it back on top in a minute. I'm going to add another key to my aggregation, and I'll explain what that is in just a minute. And I'm going to say